Now we're going to look at some examples. So we have to add or subtract the following and, if possible, reduce. So in the first problem, usually they'll do this. They start off giving you a common denominator, and normally you should go yay. But when they do that, be careful, because usually there's always something sneaky and underhanded that they do. So I've got a denominator of 4, so that allows me to go ahead and do 7x minus 9x, and that gives me a negative 2x over 4. But if you'll notice, remember the reduce. So 2 will go into both top and bottom, and I should end up with a negative x over 2. Okay? So you could either put it this way or this way if you like. But we still have to reduce like we've done before. This one, I see common denominator. So let's go ahead and combine all those numerators. Combine like terms. So it looks like 10a minus 5. But if you'll notice, I've got myself a binomial, and I could factor a 5 out. Okay? And now I get to cancel. So it looks like I should end up with 2a minus 1 over b. Remember, I like the canceling thing. This one, common denominator. So let's go put our numerators together. Now, when you put your numerators together, notice that you got yourself a trinomial. And, you know, the first two problems we had to reduce, more than likely we have to do here. Go and see if you can factor the numerator. Pause me for a second. And actually, you can factor. And if you'll notice, the x minus 1s will eliminate, and I should end up with just x minus 8. And there's my answer. Let's see what these other problems are. Still, they're staying nice. Whoopsie. Common denominator, so let's put our numerators together. Be careful here, because when you have a subtraction, you're subtracting the whole numerator, and if you remember, a negative will change all signs. Now combine like terms. That would give me what? 5x minus 15. So factor again. Pull out a 5 here, and looks like a 2x on that one. Notice that I've got common factors back here that can cancel, and you should end up with 5 over 2x. There's that one. Okay, now, denominators are not the same, so I've got to get a common denominator. I see an x times y here, and y times y here. So, the y's have the most they've been used in any one denominator is twice, and I also have to use the x. So my common denominator would be x y squared. Here we go, a building. What I have missing here looks like a y, so I'm going to have a 3y here. And this one looks like I'm going to have a 2x. Denominators are now the same. Now I can work with my numerators, and it looks like I should end up with 3y plus 2x over xy squared. No factoring can be done here, so that's my final answer. I usually think these are the easiest because 9 times out of 10 you can't go any further with those. But when they give you a common denominator, watch out. There's always something up their sleeves on those. In this one, my denominators are different. So like we had earlier, if the denominators are totally different, no factors in common, then the combination of those will be your common denominator. Now, check and see what's missing. For my first fraction, I see the x minus 3. I don't see the x, so I've got to multiply top and bottom by x. In this one, what's missing is the x minus 3. So I need to multiply top and bottom on this one by x minus 3. So let's see if I wrote that down. Denominators are the same, so hold on to them. Your numerators, go work with those. We're going to have to eventually distribute. If you'll notice, I went ahead and put them together. Now distribute, that would give me what? 7x minus 21. Combine like terms, this looks like 11x minus 21 over that denominator. And I can't reduce. That's my final answer. Three more problems. Let's see. In this one, we can factor a 2 out of this one. So normally I go and factor first. Common denominator would be this one right here, since this one is already present here, like that 7 and 14 that we had on the other one. So my common denominator would be this. So I've got to build both fractions. This one I already know is going to be 7. If you already have that common denominator, then that fraction's already done. This one's going to have to be built. Looks like I need to multiply this by 2, so I should end up with 8 on that one. Put them together and we should end up with 15 over that common denominator. Okay. This one, let's see. We can factor out an x here and an x squared on this one. So let's see if I did that. Common denominator, the 3x minus 2 has to be present, and also x squared, because I have to use the factor the most it's been used in any one denominator. So this is my common denominator. So I'm going to have a 2 here. This one I need to multiply top and bottom by x. I'm going to have a 3x there. Common denominator I have, get the numerators together. But watch it. Do you see this one and this? They're the same. So I can cancel them if I can get rid of my box. So I just end up with 1 over x squared. See, now this one, got to go factor. This is already done, and usually I've seen patterns here. 95% of the time, if you have a denominator that cannot factor, then that denominator will be present in this one. So go factor this and see if x plus 7 is here. So pause me while you go factor. Now the next part, I'm going to put down the factored form on this one. It should be x minus 9, x plus 7. Notice it's present. Common denominator, well, since that one's already here, my common denominator will be this piece right here. This one will already be x plus 8. This one, though, what's missing is an x minus 9. So x minus 9 goes here. So I multiplied. Now be careful here. Here's a negative. So put those fractions together, and now just work solely with your numerator. Distribute the negative 1 through, and we'd end up with a negative x plus 9. Now if I can get rid of my box, thank you. Combine like terms, the x's eliminate, I end up with 17 over that thing. And that's my answer. So that's adding and subtracting rational expressions. Thank you.